Hello, welcome to the second workshop of the Internet Computer BUIDL Bitcoin Hackathon sponsored by Encode Club. I'm so happy to see you in such large numbers. Yesterday we launched this hackathon with an amazing launch event and the first workshop by Jordan from the Emergent Labs. Today we're joined by another amazing speaker, Kyle Peacock from the DFINITY Foundation, who will be holding an amazing workshop on Intercomputer's native language, Motoko, and building Frontend. So basically, he'll be covering the whole full stack dApp development. So Kyle, welcome, and as soon as you're ready, feel free to share your screen and start presenting. If you have any questions, I please do encourage you to ask them in the chat or in the questions tab down below. And Kyle will get to them either throughout the workshop or in the end, whatever he sees fit. So
yeah, definitely. And do ask questions along the way. I find that saving them for the end tends to never really happen. So yeah, definitely shoot along. There's going to be a lot that we're covering for full stack dApp development and Motoko. So really do stop me if you have anything that you want to know. So I'm going to start here. We can go over to, once we get over to the front end portion, we can jump back over to like a VS Code project. But I just wanted to get started with pure Motoko. And if I'm correct, this will be everyone's first introduction to the Motoko language. Is that right? Great. So Motoko is a programming language. We use it to write smart contracts. It is specifically a language that is meant to compile into WebAssembly, which is the primary runtime for the internet computer. It's what all of the contracts will run in. And so Motoko is designed to be a nice abstraction that'll help you understand closely what's going on with the internet computer application lifecycle. So we like the actor model, which is why all of your dApps are going to start with an actor. Here you can see a couple things just got auto-completed. And I'll bump this up a little bit. So the first things that we start with are a variable and a function, right? Starting with the function, if you label it public func, that'll mean that this is going to be part of the public interface that'll be running on the canister. This will allow any other canister or a application that's using the actor to go ahead and be able to call this method. The name is the name of it. The arg will be of type text. And we're always going to return an async response. If you don't really have anything, the default return value will be a tuple, which is just empty parentheses here. So this already satisfies that requirement, but you'll see if we return something like a text value, the editor will tell us, oh, this is a literal of type text, which is not the same type as the expected return value. So that's an error. If you have a line like this, where basically it evaluates to some value of like type text here, this will be returned by default. You have two options to prevent it from being returned. One would be to assign it to something by doing a value, let hello equal hello. Then it's not actually going to return the value as if it's left alone on a line like this. You can also ignore any value and it will not be returned. Just some tips for as you get ahead going on with this. You can also explicitly use the return keyword, and especially if you need to eject early or something, but that is optional. you'll see, I think a lot of the style guides omit the return for Motoko. And yeah, lots of different ways that you can approach it, but you have options. Now, another thing that we have up here is a variable. We have two types of variables, let and var. Let is going to be the static value. It cannot be changed. If it needs to be mutable, use var for variable state. And we also have this keyword here, stable. Because Internet Computer smart contracts are able to be upgraded, this means that we're able to change the running code in the contract and replace it with new code as long as there is a controller of the application. In order to make sure that the state of the application is persisted across upgrades, we have stable variables as well as pre and post upgrade hooks, which we don't need to worry about just now. Generally, your best plan is to use a stable entry, and that will be automatically serialized to stable memory and available the next time that you upgrade. So if we say, like a new function here, public func increment, this doesn't require an argument. Again, it will yield a async response. And in fact, we can actually return the value type here. So we'll just say that this will be a natural number. So we will say state. To reassign a variable, we use :equals. So state is equal to state x1, and we can return the state. So that'll increment the value. And let's go ahead and run this. So I am deploying the canister. This is actually going to be deploying the canister to a real canister, which is a canister is again what we call a smart contract on the Internet Computer. So I can increment, call this a few times. And so there's a real canister on mainnet that is getting updated. It has this state. And that's pretty cool and all. But you'll notice that it takes like 4 seconds to do an update. And when we're building applications, we want stuff to be speedy. So let's say I want to get the count, and I want that to be fast. What I can do is I can make a query method, and a query can be something that doesn't need to modify the state of the application. And this one will just return the state. I've labeled this a query func. And so now when I deploy this, two things are going to happen. The count should still be 3 after the last few times that we've incremented it. And also now we have a query func, which will allow us to check that really fast. So I'll deploy this. Instead of reinstalling, I will upgrade the canister. Also worth mentioning that since there's no change to the existing methods or stable memory, this was a compatible upgrade. We didn't get any warnings about errors. Candid compatibility is something a little more of an advanced use case, but anyway, here we go. So we've got Our getCount method is now here in the canister interface, which we can query, and in 0.2 seconds, we got our query back. I can increment it a couple more times. And so the updates will take a few seconds, but then the queries will be fast. So it's a good pattern for your application to have whatever you can or whatever your application needs be available as a query, but then also expose updates, which can take a little bit longer. Are there any questions at this point?
Seems like we have a couple of questions. One is, what does the random button do?
What does the what button do?
The random button.
Oh, the random button.
Yeah.
If you have arguments to your method, the random button will fill in random information for those. So if we add a public func echo, this can actually be a query. So it'll just return the message that's sent to it. This will populate that with like random information. This can be really helpful if you're just sort of like verifying, there are junk testing libraries or whatever. But this has implementations for most types of inputs. So with text, I called it, and it just gave me some random garbage, which then the canister can repeat back.
Cool. Thank you. There are a couple of more questions. I don't know if you want to take it now or at the end.
I do want to take them now, yeah.
Cool. There's a question of what does this canister do, and why is there a timer next to it?
Yeah, great question. So the playground is giving you a real canister, but you're getting borrowed time on it, basically. So it provides you this free service where you can deploy a running canister on mainnet. But at the end of that time, you'll never be the controller of it. You're just sort of like borrowing some time to run on it. And it'll reclaim that canister at the end of this countdown. So it's not kind of a permanent thing, but just to demonstrate that it is in fact live, we can go to dashboard.internetcomputer.org, search for this canister ID, and you'll see, yeah, here it is with our echo, our get count, and our increment. Here in the dashboard, and it is just like running in the real world. It's just that it's only got a limited lifespan.
Cool. Thank you. There is one more short question. Karsten from DFINITY is actually helping out in the comments as well. But I guess the question is, should we always have async returns from the interface?
Yeah, so for any actor function, you will want to have an async response. It's just reflective of the fact that something asynchronous is happening. It's also required for some more advanced use cases, like talking to other canisters. Certain other more advanced use cases also involve async behavior. But you can have functions like a helper function, like public or just private. And if another method wanted to use this, it doesn't need to have the async. It doesn't return an async type. And because if you use within a function something that has an async type, you must await it in order to get the response. But if you're just, excuse me, if you are simply using another function from like a library, or you can have other files that you can import from for other modules, something like this. If we've got our utils.mo, we can have a module and a public func of add. And we can use the method that's exposed over there in our module. So as you scale up your application, this will be a good way to sort of divide up your code, make things more reusable across projects, stuff like that.
Cool. Thank you for the answer. I hope that answers the question. We have two more, if you want to take them now. One is, I guess they're asking, why would you recommend learning Motoko instead of Rust?
Let's see. There are some benefits to Motoko. For one thing, it actually produces leaner WebAssembly modules. Rust ends up packaging quite a bit more information in, and the CBOR implementation, the serialization to and from Candid as well, ends up adding a bit of overhead. So you can have a more performant Motoko application on the internet computer in a number of cases than a Rust canister. Now, that said, Rust does tend to have better performance on large data sets and parsing through them from our testing, but you can have a very lightweight application, takes up very little space, and doesn't have too many dependencies with Motoko. So that's one reason you might pick Motoko. The other really is the language design. If this feels more approachable to you than Rust and you don't know either already, that's a perfectly good reason to use it. The design of Motoko is meant to be a simpler process, particularly in terms of managing stable memory, having your Candid interface. There's just a little bit more that we're able to do for you in terms of the tooling to make it convenient. So yeah, that's the other thing. Reasons to pick Rust is, of course, its excellent suite of libraries that are available on crates.io? But crates that are published for Cargo. You've also got some really robust testing and other. The community is larger than even just Web3, so there's just more ability to go around and have people already have encountered the problems that you might encounter. These are the trade-offs that you evaluate when you're choosing a language. But I do a lot of my programming in Motoko, and I find it pretty adequate for a lot of what I want to do.
Cool, thanks. And I think the final question there is for now that hasn't been answered already is about stable lists and how to survive the breaking change. Chen asks or says he tried to save the hash map by converting it to a stable list on pre-upgrade.
Yeah. So there are a few different strategies for serializing something to stable. The most classic approach is an array, simply. And the array, of course, can be of type. If you have something that is like a class, such as an iter or a hash map, what you'll need to do is you will need to serialize. You will add a pre-upgrade that. I need to double check the syntax. Yeah. But you'll need to add a pre-upgrade hook in order to take the information and turn that into an array that you've already defined as a stable variable. What I'm going to recommend is try to stick to using information from like the basic types or an array of those types. Or there's also from the mops.1 package registry, which I'm going to show everyone how to use in a second. There is a map, stable hash map. And this is going to be the way that I'm going to recommend if you have like a map of information of key value pairs. I'm going to recommend to use the stable map as your go-to tool here.
Cool. Okay, thank you. I think that that's it from as far as questions go for right now. So I think you can proceed with the workshop.
Cool. So let's go ahead and actually start with DFX new. I'm on DFX 14, I believe. All right, underscore. So I'm creating a new application. It's Motoko by default. If you need Rust, you can specify type Rust in the DFX new command. So here in the example, I'm going to go ahead and install the mops package manager. Install IC mops. I'm going to run npx, which just allows you, if you're unfamiliar, allows you to run commands out of your node modules. npx mops init. So this is installing the base library, and it's giving us a mops.toml file. I'm also going to go ahead and add the map library. So now if we come up into the backend that we're given, and I want to add mops, I can just do import. It's not actually out of base, but map. And what did the guide say? Map. Map. And so the name is determined by what it's registered under. I know that in their docs it says hash map, but because the name here and my dependencies is map, that's what I install it as. So we've got our map. I can do a really quick I'll do p hash in this case. Cool. So we can create a map here, and the p hash or the whatever hash are going to determine, it's just like a hash of a particular type. In this case, p is for principal. So we can actually have here a stable map that will do a principal to nat hash map. And it just needs to be passed a method that's going to reproducibly hash whichever type over and over again. So this map is already serializable for stable, and it can store principal and nat. So before, remember when we had the increment, we had information that was just a global increment that we were going to do. Actually, yeah, I'll do that here. So we had a global increment because we just had a single count in our example. Here, let's make it so that the caller of any method is going to be the one who gets their principal or their individual count incremented. So the way that this works is the internet computer will reveal anytime that a call is made, the cryptographic public key that is attached to the signature. All updates on the internet computer have signatures attached to them. And we can reveal the public key in a particular format, which is called a principal on the internet computer. And in order to access this on any method that you want to expose, you can say shared. And we can look into this shared object and pull out the caller. So the caller will be of type principal. And we can actually use this as access control. So yeah, actually, before we do increment, let's do get count. And this one will look into the map, and it will return map dot. Let me double check the syntax here. So we've got map dot set, map dot get. Oh, right. It needs to get the p hash passed. Is results. Yeah, so that is an optional nat because it may or may not have a count. And so what we can actually do is return a switch based off of the result. And this syntax here reflects the two options. So an option can either be, if you do a switch on it, it can be of null, or it can have a value. And this is the way that you're able to reference those values. So if the value is null, we'll just assign it to 0 because we want to return a nat, and you haven't updated anything yet. Otherwise, we will actually return the value. And again, remember, this is a query, so we can do, this is a shared query. And we can actually do a similar increment. Same logic. So first, let's call, instead of result here, let's call this initial. So the starting value, then let's figure out, instead of put, it's map.set. Cool. So this is basically the same logic as before. We've got our default value, where we figure out what it was before. We set the map so that for future calls, we know what the new value is. And then we can update it. So right now we're on a local network because I'm running it on my own computer. I'm going to start the DFX local replica. This is built using the same code base as the live internet computer replica. So it's a really great runtime, and you can do all of your, or a great deal of your testing locally. I'm going to deploy just the backend because the front end actually doesn't know about any of what we're doing yet. Example app backend. Package map not defined. Ah, right. That was a bit of setup that I didn't do. Here, we have to tell DFX what our pack tool is. So we'll try that again. Yeah, this should be fine. An actor class. Oh, right. This was in the wrong spot. So that error message was telling me that inside of an actor or a module that declares an actor, you can't have logic outside of the actor. It needs to all be scoped within it. But now we've deployed it. We can check our local replica. And so the interesting thing is here, everyone by default as a principal is going to have an anonymous identity. The anonymous identity is based off of the way that you would encode a principal using just like zeros. It's not very secure. You shouldn't be. You should probably disallow the identity in most of your applications, and I'll show you how to do that in a second. But for now, it actually lets us use the candid UI. So first, we can check our count. It's 0. We can increment it. And so we've incremented the count a few times here. Hopefully this isn't a surprise. But if I call the same canister using my DFX identity, and I call getCount, my DFX identity gets back 0 because it's a different identity. It's a different caller than the anonymous identity. So this means that everyone will get their own personalized view of the state of this application. It took a little bit to get it running, but hopefully this isn't too daunting. I think it's actually a pretty friendly way to structure your applications. This is probably another good spot to pause and answer some questions.
Sorry, I had a little bit of internet trouble. But yeah, we do have a couple of unanswered questions. So one of them is, how do you assign a canister per user instead of having just one canister for all users?
So the way that you're going to need to do that is basically you need the ability to create canisters, which is something that requires a cycle balance so that you pay the fee and then you top it off with an initial balance. So creating a canister per user is feasible, but it's a little more complicated, right? For most beginner applications, it's probably best to consolidate to a single canister architecture, unless you have a plan that really calls for one canister per user. But if that is the way that you want to go, the steps that you would need to do would be the first step would be call management to create a canister. You would then need to install the code. So you would need the WASM module that is going to run on that canister. You would need to set controller to the user, and then you would need to remove to the canister so those are the steps that you would want to go through. Up on my GitHub, I've got a repo that sort of just shares the management canisters candidate interface. We're not going to get into that here, but that's basically the logic that you'd want to go through.
Cool. Amazing. Artem is asking, can we call a canister from the terminal for the specific caller or identity using the actual identity of some deployed canister to debug inter-canister interaction?
You want to use the identity of the canister itself, or simulate that?
Yes, I think so. I'm not sure. Artem does this.
Yeah. Well, if that is the case, no, there's no strategy for that. You have to actually instrument the logic in the canister and allow it to sign its own calls. DFX can't spoof that for you.
Awesome. Thanks for answering the question. I hope Artem this is a satisfactory answer. One more question from Artem is, can we deploy two canisters to distinct geographical regions, and how to control that?
So no, canisters are deployed inherently. They're deployed globally. So the whole point is that they're distributed geographically and deterministically by the network nervous system. You have some discretion in being able to run your own HTTP gateway, which may be more of what you're interested in, and you can have some choice in like picking that or working with a provider to offer access that's different from IC0.app or ICP0.io. You can offer your own, but yeah, the ability to deploy to specific hardware is abstracted for you, and that's kind of it's a key part of actually the security properties in the design of the internet computer.
Cool. Awesome. I think that's it as far as the questions go. Everything else has been. Oh, Artem is actually typing something. Let's hold on a second. But everything else has been answered. Thank you very much, Karsten, for covering the comment section as well and helping out with the questions.
So in the interest of time, I'm not going to live code this front end, but I do have an example already published. So here's some information. This is a vanilla JavaScript. I tried to keep it generic. But basically, when you want to interact with this kind of one counter per identity kind of concept, you obviously have a button in your front end somewhere that you're going to click for that. But here I have two different strategies for how to create an identity for your users. In a lot of the crypto world, all interactions start with like a wallet and have like an extension. Because we don't necessarily care, there's no transaction that's involved in this type of application. In the internet computer, we tend to start with identities where we don't actually focus on tokens as the primary way that you interact. So we have a series of libraries for doing things like authenticating with internet identity, an authentication provider we have. We also have libraries to just generate identities which are capable of signing requests to the internet computer. And the basic structure of how this works is you start with an identity, you attach it to an agent, which is going to bind to the whatever the fetch or HTTP implementation is required to make calls for the ecosystem you're in. So we have an HTTP agent in JavaScript. And then we have an actor, which takes the HTTP agent and also creates a bunch of methods based on the canister interface. And the way that that looks is something like this. We can automatically generate this for you based off of the canister interface. You don't really need to read or modify these, but this gets generated into JavaScript, which can then make the calls to your canister. And the way that that gets set up is with this create actor logic. We don't need to get into all of it, but the basic gist is we create an agent, an HTTP agent. We create an actor using that interface that I just showed you, as well as the canister ID and some other configuration options. And with all of that together, that gives you a setup interface, which can look like a default actor. Yeah, it's a default backend actor, and you can just call it like you would any other function. It'll be a promise-based syntax, so you can just await the response of any updates or queries that you want to make. So this logic, let's jump into the identity logic here. All of this here is basically just like rendering event listeners. You can look into that at your own leisure. But here is the core identity logic that I want to get into. This is important for access control. So we've got a couple snippets here. One is using a pre-existing login button. The login button wraps a package which is at DFINITY/auth client. You can use that as well. We also have documentation, and I've got a link that I can provide at the end to my off-client demo project, which has starters for React, Vite, Svelte, and vanilla JavaScript. But yeah, so we've got logic to set up the login button, which is a web component, to configure it so that it points to internet identity. This all makes it work locally or remote. And then the second logic that we have down here is this seed to identity. This is where we take a password input, sort of just like type in a secret, and we can turn this into a uint array by encoding the secret, and then we can use that secret to generate an ED25519 key identity. This will give you a reproducible identity from just a simple password. It's a really low barrier to entry way to get started with identities. You can also use this for like testing purposes and whatever you want. But yeah, other strategies involve like if you want to do like a full seed phrase using SecP256K1, we have a specific library for that. Whereas the ED25519 and also in ECDSA are available in the main DFINITY identity package. There's a lot of options here, but the point being, think about how it's going to be best for your users to get an identity. You have these options to generate an identity statically. Having something like an authentication provider with the II login button is going to be something that's useful for having a little more safety and fallback logic in case your users forget their seed phrase or make any number of mistakes that are classic problems with Web3. But if you have the specific need also to have more information for your or if you want to have like a wallet extension, I'm forgetting the code base here. Maybe it was create IC app. Yeah, it's used here. This is it. Connect to IC core. This is a great package to look into. It creates this nice little pop-up window that allows you to authenticate with several providers that are popular in the internet computer ecosystem. So if you're doing Bitcoin applications, this is probably a great place to go to so that you can authenticate with internet identity, AstroX, Infinity Wallet, Plug, NFID, Stoic Wallet, all of which have their own user interfaces for viewing balances. They all have their own documentation as well. Particularly, you'll have trouble for like running it locally during testing. I know there's a lot of challenges there, but at least for the user interface, this gives you a really nice quick start, and it's basically going to give you agents. So when we were back over here in the code base, this create agent from here, or create actor, you can pass in an agent to it. And so you would take the agent that you would get from Connect2IC and pass it into your actor, and then you would be good to go. So you would skip like all of the setup steps because those libraries take care of that for you.
Cool. Awesome. If that's it, I think we can move on to the final block of questions. How's that sound, Kyle?
Let's do it.
Yeah, sure. There are a couple actually. First, would you mind sharing the GitHub repo link into the chat so people can access it?
Yes.
There we go. Awesome. So I think we have 3 or 4 more questions. So one of them is how to send large chunks of blob to frontend. So Chan is trying to send, for example, 20 megabytes of blob data in the backend, but response limit is more or less 2 megabytes. So is it possible to send a partial response to frontend, which will then know that there's an incoming partial response?
There are strategies around this, but basically the internet computer is fairly unopinionated around it. One exception to if you want something that has a little bit more of opinion, there's the assets library. So by default, we give you a front end of type assets with like the DFX new. So this type assets has a well-defined interface. And this asset manager is able to upload assets, large assets, to the asset client, basically. So one strategy could be if you just sort of define your large amount of information that you want to upload with like an established file type, you can upload it as an asset. And this is probably the easiest strategy because it handles all of the chunking and the uploading for you. So that's what I would probably reach for. But you're welcome to sort of choose any number of different strategies. But yeah, you'd kind of have to roll it yourself if you didn't go with asset canister plus asset manager.
Yeah, cool. Thank you for the answer. Artem is asking or building on the previous questions, on the previous question of geographical distinct locations. They're asking, it seems that canisters are deployed to the same subnet by default. Is it possible to deploy them distinct subnets which are geographically separated to improve reliability?
Subnets are not geographically separated. The subnets are geographically distributed. And the reliability, like you're not going to have canisters, like a majority of your canisters based in any particular continent. The whole assumption is that we're basing it around zero downtime through geographical distribution already for you. Queries will be routed to the closest canister, but updates will have to talk to the canisters that are provisioned in your subnet, which are distributed throughout the world.
Cool. Awesome. A question from Armando, who's asking about imports, which each import will take some cycles, right? Is it best to use as few imports as possible or not?
So it's based on like what gets bundled into your client application. There is a hard limit on the size of a canister WASM module, which really is like 2 megabytes. And since like you can have gigabytes worth of like heap memory storage per canister, the size of your canister in terms of cost doesn't really make that much of a difference. Now, it's still worth evaluating the performance of your application. And there are multiple strategies for doing this. We've got like a profiling repo on the DFINITY GitHub, which will show you some benchmarks as well as the tools that we use to create those benchmarks. But there's like an experimental cycles API that you can reference. Which apparently is hard to search for. Oh, there we go. Experimental stable memory, experimental cycles. So this API allows you to like show your cycle balance, and you can basically like use debug prints. You'll have equivalent performance on your local replica for whatever a cost takes, or whatever a call takes up. So you can get a good idea of how much different updates are going to cost before you even deploy. That may look a little different if you've got more complex use cases like cross subnet calls. But generally speaking, yeah, you're going to be able to profile your cycle performance on any particular method you need.
Cool. Amazing. It's 2 minutes to 6 Central European time, so I think that about brings us to the end of the workshop. Big thanks, Kyle, for the wonderful workshop and for answering all the questions. It's so wonderful to see so many eager people in the comments wanting to know more about Motoko and about the Internet Computer. So that's pretty much it for today, people. We'll wrap it up here, and I hope to see you tomorrow for the workshop on Rust. Thank you. Goodbye.